So in this one we are going to explore logistic regression, like in the deeper than what we have been through in the last video. So we are going to explore how this does uh, forward propagation in step of logistic regression. So we're going to write some equations here now. So uh, zi, which is our z, which is our normal traditional function. uh, by the way, it is not I, it is 1, x1 plus b, and a1 is going to be z of 1, and this is going to be activation function, and this is going to be z, and this is our prediction of the first example. So that's how we're going to write prediction of the first example. The second will be z2 is equal to wt plus x2 plus b, and activation will be a2 z2, and this will be prediction of the second example. Now we will be having m examples like this, and we will be having the prediction of mth example like zerium, and you guys can get that. So predictions without for loops in rem training examples are really important. So what we're going to have, we can have these things: x1, x2, this is xm, that's what we can call as nx comma m means the number of the terms, and nx means these values. So let's dive into the concept firstly, and then after the whole thing. Alright, so imagine you have a lot of pictures of different animals like dogs, cats, birds. You want to teach computer to recognize what kind of animal is it in the picture. The computer needs to learn from these pictures, but instead of looking at one picture at a time, it can look at all pictures together really fast, and this is called vectorization. So in order to for computer to understand which animal is in each picture, it will need to do four things. So firstly, it will look at the picture and decide if it is the animal or not. Secondly, it tell the computer how good the answer is, like 1 to 3 out of 10. Then third thing it will do is look at another picture and decide if it is not animal or not. Fourth thing it will do is tell the computer how good that answer is for other picture or not. And then the computer needs to do all these steps really fast, so it can learn from all the pictures together. This is called logistic regression. So I hope the concept of logistic regression is getting clearer with the different kind of examples I'm coming up with. So now instead of doing each step one by one, we can use vectorizations to do them all at once. So it's like doing all the math problems in a book at the same time. So we create the special matrix, which will be looking like w x1, then b x2, and this matrix is a like recipe for a computer. So we take the bits which are w and multiply them with the inputs x, and then add the bias which is b. This will give us new number z, and we drew this for all pictures, and it will look like z1 and z2 up to zm. This matrix is like big list of numbers that computers can use to understand what's in each picture. Now we want to find out how good each answer is. So we create another special matrix called A, which will be looking like A1, A2, and to AM. So we are going to look at the mathematical aspects of all these, but just get the concepts clear. Alright, so the matrix is like report card for the computer. It tells us how well it did on each picture. So we can use vectorization to do all the steps really fast. Instead of doing one step at a time, we can do them all at once with just one line of code. So that will be really awesome, right? Instead of doing all those for loops again and again, we can do whole thing in one line of code. But here's the thing, we need to be careful when we are working with numbers in math. Sometimes we need to add or multiply numbers that are different sizes, and that's where broadcasting comes in. So it is like how you can use the simple pencil to draw a big picture and write a small note on it. So vectorization is like doing all the math problems in a book at the same time, but using special matrices and recipes to help computer understand what's in each picture. So let's get back to the math of all these things. So we were here. So one line of code execution of this thing will look like gi, this is not I, z1, z2, z2 up to zm, which will be equal as transform of w x plus all the b's, value of b's until mb. So this will be equal to like 1 by m, cause the values will be going up to m. So the row vector which w will be, we are writing w will be, it will be row vector, right? So x1, x2, xm. So what we are going to write with these equations is z is going to be equal to z1, z2, zm, which will be going to be equal to wt x1 comma wt x2 until wt xm, and these things are going to be 1 into m. So we are going to add b plus b in each term, and the Python implementation of this whole thing will look like z equals to np dot w dot t x plus b. So this b will be added as these b, and these b's are going to be mb. So we are going to add something in this equation, and that can be different in the term of like vector number, so it can be different number of dimensions, and there is a way in Python that it can be understood in the mathematical way, and that's the term what broadcasting is meant by. So that's what I was trying to explain in the explanation previously. So if you paid attention, then you're catching up with me now. So then after that I'll be getting these as well. These will be activation functions of the equation. We'll write these as like this. So just keep these in mind, and we are going to explore what broadcasting is in what broadcasting is as a concept. Alright, so uh, let's dive deeper into the concept in next video, and until then, keep grinding and keep being legendary, guys. See you in the next one.